Today we're going to talk about the law of sines. The law of sines is used for solving non-right triangles. Non-right triangles are also called oblique triangles. Non-right triangles, also known as oblique. All oblique means is not a right triangle. Okay. But it's only used in certain circumstances. So the law of sines is used if you have an ASA triangle, an AAS triangle, or an SSA triangle. Today we're just going to talk about the ASA triangle and the AAS triangle. The SSA triangle is a bit of a longer process, so we're going to save that for another day. So let's talk about what an ASA, an AAS, and an SSA triangle look like. Like, what are they talking about? So it's all about the information that's given. So an ASA triangle means that you're given first two angles and a side, but not just any side. The side that's given is between the two angles. So I have an example here. We can say, this picture's not drawn to scale, sorry. We'll say this is 61. And we'll say this is 112. And we'll say that this side here is 4. So this is an ASA triangle because I have an angle, a side, and another angle. And the side is between the two angles. An AAS triangle, on the other hand, might be something like so again, we still have two angles and a side, but now the side is not between the angles. See, here are my angles. The side that's between the angles would be this side, but that's not the side that's given, it's this one. Okay, and then finally an SSA triangle. Not that we're going to do these today, but that's okay. We'll say this is 19, and then we'll say that this is 10, and we'll say that this is 8. So as you can see, there's two sides and an angle. So here's the side, and here's the angle. And notice that the angle that's given is not between the sides. See, if the angle was between the sides, that would be this one here. And that's not the angle that's marked with a value. Okay, you should have learned that in geometry, but I know it's been a while, so. Okay, so here is the law of sines. So let's get this written down. So little a over the sine of big A equals little b over the sine of big B equals little c over the sine of big C. Okay, so a couple of things here. Little a, b, and c are always used for side lengths. And the capital A, B, and C are always used for angle measures. And the relationship between lowercase a and capital A is that lowercase a is the side that's across from the capital A angle. So for instance, if we take one of these triangles we had up here, maybe I call this angle A up here, and this angle B, and this angle C, and that would make this side have to be lowercase a. See, it's the side that's across from it. And so side little c would have to be over here, and side little b would have to be over here because, again, it's across from angle B. So a side that has a little letter on it doesn't touch the angle who has the matching letter. Okay, This is usually how the law of sines is written. It can also be written upside down. So sine of A over little a equals sine of B over little b equals sine of C over little c. It doesn't matter which way you write it. It just, whatever you feel like. You're really only using one pair of these at a time. But all together, all three of those little fractions are congruent. And you can use the A over sine A with the C over sine C. It doesn't matter that they don't touch each other because they're all equal. So let's start with an example. So here we go. We have this triangle here, and this stuff has all been given to you, so you have this on your paper already. So solve the triangle. So first let's review, what does it mean to solve the triangle? This means to find all the missing sides and angles. Okay. All right, step one, we're going to look at our triangle and we're going to identify what type of triangle it is. Meaning, well, first of all, is it a right triangle? Because then we could just stop all of this. Is it an ASA, an AAS, an SSA? And of course, there are other types too. They just don't use the law of sines, and that would be SAS or SSS. But we'll get to those another day. So what kind of triangle is given? So I have two angles, and I have a side. So it's either AAS or ASA. The question is the side given in between the angles? And the answer to that is no, because if the side given was between the angles, that would be this side here, and that's not the case. So we have, in fact, an AAS triangle. And the reason why it's important to know that is because the law of sines is only one of the laws. There's also the law of cosines, but one thing at a time. So in the end, you'll get a triangle. You'll have to determine what type it is, because then you're going to have to determine which rule you use. Okay, so next what we're going to do is we're going to list the known values. It's good to be organized. So capital A, that's given, that's 46. It's on the picture. Capital C was given, that was 63. And side little c was given, so that's 56. And everything else is unknown. Okay. And we'll go back and we'll fill in the other values when we get them. Okay, so find missing. I think we should find the missing angle first, because that's going to be the easiest thing to do. So we're going to fill that in. Find missing angle. Because all the angles of a triangle have to add up to 180. So if I add 63 plus 46, I'll just do that here. 63 plus 46, I get 109. And then if I subtract that from 180, I get 71. And so 71 then is the measure of angle B. So let's fill that in, because we're going to need that. Okay. The next thing we're going to do is we're going to set up the law of sines proportion. We're just going to do one proportion at a time. The one you have to use has to be the angle with the side that's given. So I have to use sine C over C. Oh, well, that's not what I wanted to have happen, was it? Not fill. I don't want it filled. There we go. Okay. Okay, so I'm going to have to use that one, and then I'll have to do this twice, and I'll just, just do it in whatever order. Okay, so 56 over sine of 63. So that's my little c over sine of big C. Let's find A first. So little a over 46. No, that's not true. I lied. Sine of 46. There we go. Okay. All right, then we're going to solve this. So to solve this, we're going to have to do some cross multiplying. So we can do 56 times sine 46 equals sine of 63 times a. I'm looking for a, so that means I'm going to have to divide both sides by sine 63. And then that will give me a. So now you're going to need your calculator for this, and you do want to make sure that your calculator is in degrees. And I don't know how recently you've been using it. So go to mode, and then go down to the fourth thing in that list. And it should say radians or degrees, and you want to make sure that you're in degrees. Okay, after we figure that out, then you can just type that in the calculator. So 56 times sine 46 divided by sine 63. Just a note that, you know how when you hit the sign button, they automatically give you a parentheses? You do have to make sure that you close that parentheses before you hit divide, or else it's not going to work right. So I got 45.21 for A. I'm going to say let's everybody stick to 2 decimal places. So we'll just make that a blanket statement. So we'll always round to 2 decimal places. Okay, so 45.21. I'm going to come over here and put that in my list so I know. Okay. Now I'm going to repeat the process, but to find side B. I am going to use the original given information again, because just in case I made some kind of error in finding A, I don't want to use that error in finding B, because then I'm just going to make more mistakes. So 56 over sine 46? Oh, no. I'm sorry, 63. So this is the C over sine C. And we're going to set that equal to B over sine of 71. And then again, we'll cross multiply. We'll get 56 sine 71 equals sine 63 times B. Oh, God. Okay, hopefully you're not hearing all the craziness going on in the background, but if you are, good times. Okay, so this is gone, and then we're going to take our calculators and type this in. And if you notice, the only thing that's changed from this part of the problem before is that 46 is now 71, so everything else is the same. And B equals 59.43. So that's the length of the side B. 59.43. And there we go. Now we've solved the triangle because we have all the sides and all the angles. Okay, let's try another one. Okay, so now we have a new one here. I want you to notice, though, what is missing on this triangle. What's missing? I have no letters. So if you have no letters, you're going to have to start assigning people letters. So I'm just going to call this guy A, and this guy B, and this guy C. It's completely arbitrary, though. You pick whatever you want. But if this point up here is C, then this has to be side C. And then this would have to be side A, and this would have to be side B. because you have to make sure the angle is across from the side with the same letter. Okay, so if you need to go back and look up at the steps, feel free, but they're there. So first we're going to identify the type of triangle we have. So what kind of triangle do we have here? We have two angles and a side. So it's either angle, angle, side, or angle, side, angle. Is the side that's given between the angles? No, so it must be angle, angle, side. Okay, next we're going to list all of our, make a big list. So A, B, C, and little a, little b, little c. So capital A was 64 degrees. Little a we don't know. C is 82. And little c is 14, and I don't know anything about B. So the first thing we're going to do is, and again, you can go up and look if you forgot, we're going to find the missing angle first. That's the easiest thing to do. So we're going to take 64, we're going to add it to 82, we get 146. We'll subtract that from 180, and we'll get 34. And so that's the measure of angle B. So we're going to take the stuff that's given, that's this, and that's going to be the ratio that we're going to use. So 14 over sine 82 equals A over sine 64. We'll just find A first. It makes no difference, but okay, so that's going to be 14 times sine 64 equals, that's going to be sine 82 times A. Divide both sides by sine 82. And then we can put that in the calculator. So 14 sine 64, don't forget to close the parentheses on the angle, over sine 82 equals, I got 12.71. So that's A. So I'm going to put it up here in my list. Okay. And then I'm going to repeat the process. I'm going to use the same ratio that I did here. Okay. But instead of looking for A, we're going to look for B. Type that in our calculators. And I got 7.91. 7.91, yep, just double checking with my notes. And I found all the sides and all the angles, so I'm all set. Okay, let's try this one. Oh, there's not even a picture. What are they doing to us? My gosh. Okay, so let's draw a picture. It doesn't have to be a good picture at all. And just, just label it. It doesn't matter. So A, B, C. You can label it however you want, though. A is angle 50, so I'm going to put that in here. C is 33.5. And side B over here is 76. And then at the same time here, I'm going to label my sides A and C. This is a little bit hard to see. There we go. All right, so I got that set up. So now that everybody's in place, identify your triangle. So what kind of triangle do you have? You have two angles, right? So it's either got to be AAS or ASA. Is the side given between the angles that are given? It is, because it's right here. Okay, so we have this time, we have an ASA triangle. Okay, and then the next thing we're going to do, make our list. Okay, A was 50, C 33.5, and B, little b, was 76. Okay, so no difference here. The first thing you're going to do is still find the missing angle. So we're going to have to add angle A and angle C. So 50 plus 33.5 is 83.5. And then subtract that from 180, and we get 96.5. Okay. And now we'll have to use the law of sines to find side A and side C. Okay, so this is the only pair of the same letter that I know. I know the B's, and that's how the law of sines works, right? So let's come back and look at the original law. Here it is, right? So you have to have a pair of the same letter, or else this whole thing doesn't work. So where are we at here? Okay, so we have to use the B's in our little formula setup here. Be careful. Make sure that you're keeping your angles straight and your sides straight. So make sure that, 96.5 is an angle. Make sure it's going in the sine function. It's easy to mess those up. Let's find A first. Okay. So 76 sine 50 equals sine 96.5 times A. Divide both sides by sine 96.5. So 76 sine 50 divided by sine 96.5. And we get 58 point, no, that's a 60 actually, equals A. And let's go put that in our list here. Okay, and then we'll repeat the process for side C. So keeping the same ratio to start. 76 over sine 96.5 equals C over 33.5. Nope, I did it again. See, don't fall for my mistakes. Sine 33.5, that's better. So 76 times sine 33.5 equals sine 96.5 times C. Divide both sides by 96.5. Sine of 96.5, sorry. Can't get out of my own way today. And we're going to type that in our calculator. 3.5. And we get 42.22. Please round correctly. Because, you're going to have to answer these questions on the computer. And I might be nice and take your really bad rounded answers, but the computer is not. So you're really going to have to make sure that you round appropriately and answer the questions as you're asked. So if they, ask you to round to the nearest tenth, then you better round to the nearest tenth, and so on. Okay, you have to read the directions. I know, your favorite thing. Okay, let's try another example. Again, triangle not given, but that's okay. We can draw it ourselves. A, B, C. A is 40. C is 22.5. B, I don't know. Little b is 12. This is side A, and this is side C. Okay, what kind of triangle is it? It's an ASA. We're going to make our list. let's see, angle A is 40, angle C is 22.5, and side B is 12. So let's remember what's the first thing we're going to do. We're going to add those angles, subtract from 180 so that we can get angle B. Okay. So this is the ratio I have of the same letter, so that's the one I'm going to have to use. So 12 over sine 117.5 equals A over sine 40. So 12 sine 40 equals sine 117.5 times A divide by sine 117.5 . 12 sine 40 divided by sine 117.5 is 8.69. So let's write that up here. Okay. And then we'll repeat with side C. So 12 over sine 117.5 equals C over sine 22.5. So that'll be 12 times sine 22.5 over sine of 117.5, and we get 5.18. Okay. So I hope that was enough examples of the law of sines with ASA and AAS. So hopefully you'll be able to do your homework problems tonight. Okay. One more thing in this section. This is an easy thing though. Okay, so area of a triangle. So you know area of a triangle from geometry, of a right triangle. No, of any triangle, I'm sorry. Is 1/2 base times height. Well, that's great if you know the height, but if you don't know the height, then this isn't actually all that helpful. So here we have a new formula. It's based on the original one, but so if you're given a triangle that's an SAS triangle, so two sides, the angles between them, then the area is 1/2 side B times side C times sine of angle A. Now, these letters are interchangeable, to a certain extent. Okay, so notice that it's 1/2 times 2 of the sides, and then times sine of the angle that's between the two sides. So this could easily also be written as 1/2 times A times B, and then that would have to be times sine of C. You see how the angle doesn't match the sides? Or you could have 1/2 A times C times sine of angle B. Okay, so this is all the same formula, but people get freaked out if they are given the different letters, and then they just sort of, I don't know, have like a brain blip. Okay, so find the area of a triangle whose two sides are 24 and 10, and whose included angle is 62. So by saying whose included angle, they're telling you that it's SAS, even though they didn't give you like a picture. So, you got everything you need here. A equals 1/2, okay, times the two sides, times the side of the sine of the angle between them. That's it. Like, seriously, that's it. Like, it's over. So 105.95. I don't know what the units here are, but whatever the units are, it's area, so it would be, units squared. Find the area of a triangle whose two sides are 8 and 12, and whose included angle is 135. Here's the thing. Nobody has any trouble with this. You know what people have trouble with? remembering what to do. This is, I know you're just looking at this going, oh, this is totally fine. I'm not even going to worry about this. And then you'll get this question later and you won't have any idea how you're supposed to find it. So you have to remember that this is what you do. The process of it isn't hard, but you're going to have to remember like to use it when it's appropriate. So anytime you're finding an area of an SAS triangle, this is the formula. Okay, so try the homework problems, and then if you have questions, we can go over them tomorrow.